Hello maths fans! I'm back doing another exam, but this time with a twist. I'm joined by Ben Sparks, who many of you will no doubt recognise from his excellent number file videos. And the plan this time is going to be for both of us to do a GCSE higher maths exam, and then we're going to swap scripts and mark each other's work. It should be a lot of fun. The paper we are going to be doing is the AQA GCSE Higher Maths exam. This is the 2019 version, and this is paper 1, which fortunately for me is non-calculator. For those of you not familiar with the UK system, this would be taken by 16-year-olds just as they were ready to leave high school. There are a total of 80 marks available, and the time allowed is 1 hour and 30 minutes. Let's go. Okay, question 1. 2 right-angled triangles, 6, 10, y. Okay, so these are similar triangles. We've got 10 increasing to 15 because they have the same angle x. 10's increasing to 15. 1.5 times 10. 6 must increase to 9. So question 1, the answer there is 9. Good start. Question 2. Work out the value of 1 2/3 squared. So 1 2/3, that's 3/3, that's 5/3. 5 over 3 squared. Square both numbers, that's going to be 25 over 9. Hopefully that's an answer. Oh, I have to simplify it. So out of 9s, that's 2 9s, 2 7/9 is that one. Okay, good. Question 3. Work out the arc length in meters of a semicircle of radius 6. Okay, so a semicircle of radius 6. And what's the arc length? So if r is equal to 6, I know the total circumference is pi times the diameter, which is going to be 12 pi, because diameter, of course, is twice the radius. So the total circumference is 12 pi. So for the semicircle arc length, I think it wants half of that, which will be 6 pi. So I'm assuming it means just the curved bit when it says arc length, as opposed to perimeter. But I'm going to go with 6 pi. And that is an answer, so I'm pretty sure that one's 6 pi. Okay, question 4. Circle the fraction that is equivalent to 4.625. Ooh. So I know 0.5 is a half, 0.125 is an 8, so that's 5/8, so that's 4 5/8. Okay, and it wants me to convert that into 8ths or quarters, so 4 lots of 8 is 32, so it's 37 over 8, which is there, so I'm going with that, 37 over 8. Okay, going well so far, question 5 already. Right, what have we got? Oh, right, 0. Oh, this is probably where I'm going to go wrong now. Right, 0.0000097 in standard form. I'm not even sure I know what standard form means. I'm thinking it means something point something times 10 to a power. So what have we got then? So that's going to be 9.7, I think, times 10. So to the minus 1, 2, 3, to the minus 4, I think, because it's going to be that. So if I had 9.7 to the minus 4, so it'd be 0. Shift it 1, maybe 0.97, so it'd be there, then it goes to there, then it goes to there, then it goes to there. Yes, so I think it's 9.7 times 10 to the minus 4. I'm going with that. Assuming I know what standard form is. Okay. And that was 5a. All right, there's a 5b now. Oh, work out 3 times 10 to the 5 divided by 4 times 10 to the 3. Give your answer as an ordinary number. I think that just means simplify it as a fraction, I assume, seeing as this is non-calculator. So 3 times 10 to the 5, that is, so 10 to the 3 would be 3,000. Yes, so 30, that's 300,000. Okay, so that's 300,000, I think, yes. And then 4 times 10 to the 3 divided by 4,000 Okay, so 300,000 divided by 4,000, so let's cancel the zeros. So that's 300 divided by 4, which is 75. So it isn't a fraction. I guess 75 is an ordinary number, whatever that means. Okay, I go with 75. Question 6. Anna plays a game with an ordinary fair dice. Oh, this, you have to think a bit more for this one. If she rolls 1, she wins. If she rolls 2 or 3, she loses. Okay, so let's write this down. Question 6. Okay, so 1 equals win. 2 or 3 equals lose. And 4, 5, or 6, she rolls again. Okay. So this is a fun game. Not much going on where Anna lives. When she has to roll again, oh God. So, okay, so win and roll again. And if she rolls again, she rolls an odd number, she wins, or an even number, she loses. So odd equals win, even equals lose. I'm really glad the question now actually says draw a tree diagram, because that's exactly what I was going to do anyway to figure this all out. So this is perfect. Okay, so I'm going to have to draw this out myself. So first roll, we've got, if she gets a 1, and that has a probability of 1 out of 6, 6 possibilities on the dice. Excellent, and then it's game over, she wins. Perfect. Then she could roll a 2 or a 3. So that's 2 out of the 6 possibilities, so that's 1/3. And then a half of rolling 4, 5, or 6. I agree with that. And then finally, it wants me, so after a half, and then she's going to roll again. Nope, I've written that out wrong. Oh, get your diagram right. So she's rolling a 4, 5, or 6 with probability a half. And then from there, we've got a half to get odd, or a half to get even. Okay, fine. I'm happy with that. Oh, wow. Here we go. Is Anna more likely to win or lose? You must work out the probability that she wins. Right, I can do this. So what do we know here? Let's use a different colour. So I know that if she rolls a 1, she wins. So this is 1/6. So this is a win, and the probability of that win is 1 out of 6. If she gets 2 or 3, immediately she loses. So the probability of that loss is 1/3. Now, the other ones, so she's got a half and then a half. What did she do if she got odd? I wrote it at the top. Odd is a win, so this is a win again. So this is P over win, and that's going to be a half times a half, because you multiply them, so that's 1/4. And then it's a half times half, so it's going to be another 1/4 probability of this loss. And now I'm going to check I've done it right, so they should add up to 1. Always check this on your tree diagrams. So 1/4 is a half plus a third. So that's 3 out of 6 plus 2 out of 6 plus 1 of 6. Perfect. Total is 1. Okay, I'm happy with that. So is it Anna more likely to win or lose? So the total probability of winning is going to be the 2 added together. So that's going to be a 1/6 plus a 1/4, which I'm going to have to work in 12ths. So a 1/6 plus a 1/4 is 2 out of 12 plus 3 out of 12. So I think that's 5/12ths, which means the probability of a loss should therefore be 7 out of 12. I'm going to do it properly to make sure I'm right. So a 1/4 is 3 out of 12, plus a third is 4 out of 12, so it is 7 out of 12. So she is more likely to lose. So more likely to lose. So let's write that. More likely to lose, and the probability of winning is that 5/12. All right, question 7. 3 friends arrive at a party. Okay, fun. So 3 friends are arriving. Their arrival increases the number of people at the party by 20%. Okay, so what do we know? Increases the number. So X is the unknown people. Okay, so X equals original size. And we know that it's going to increase that by 20%. So that means that X over 5, which would be 2 of x, or 1/5 of x, 20% of x, 0.5 of x, sorry, 0.2 of x, or x over 5, is equal to 3, I think. So I think x is 15, so that means x is 15. So, and then the 3 have arrived, so I think originally there were 15 and now it's gone to 18. Now let's check that makes sense. So how many people are now at the party? So I think now equals 18 people. And I think originally equals 15 people, because then you could say 20% of 15 is 1/5 is 3, and 3 arrived and it increased by 20%. Yes, I would agree with that. Okay, so how many people are now at the party? 18. Question 8, work out the value. Ooh, this looks awkward. All right, we can do this. Question 8. This is basically just me doing a calculator paper last time, but now I can't use one because I couldn't use one even when I was allowed. Right, work out the value of 3 to the 12 divided by 3 to the 5, and then we're going to divide that whole thing, divided by 3 squared times 3. So 3 squared times another 3 is going to be 3 cubed. Right, so what we've really got here then is 3 to the 12 over 3 to the 5 times 3 to the 3, which is 3 to the 12 over 3 to the 8, which is 3 to the 4. Okay, probably wants it in numbers, doesn't it? So let's do that. So 3 to the 4, 3 squared is 9, so 3 to the 4 is equal to 81. So the answer is 81. All right, question 9. A shaded semicircle, diagram and a half. A shaded semicircle is inside a circle as shown. Okay, I'm going to have to copy this out then, aren't I? So what have we got? A shaded semicircle, right, so we've got a circle and then that's 8 across there. So that one is 8 centimeters. So that means the inside one has a radius of 4. That's going to no doubt be helpful. And the big one has a radius of 10. Right, okay. Okay, how many times bigger is the unshaded area than the shaded? Right, so let's work out the total of the outside one, so the big one. So big circle area is pi times the radius squared, so that's 100 pi. The semicircle area is pi times the radius squared, which here is 16. So that's 16 pi divided by 2, so that's 8 pi. So what do we want to know? How many times bigger is the unshaded area? So the shaded area, okay, so I think the shaded area is 8 pi. So the unshaded is 92 pi. So it's, how much bigger is that? So therefore 92 divided by 8 times bigger. Probably simplify that. That's 11 and a half, I think. 11 times 8 is 88 plus, yeah, so it's 11 and a half times bigger. Okay. I hope. Meh, let's move on. Okay, question 10. The number of items n, interesting, made in 1 hour by a machine using by n equals. T is the time in minutes the machine takes to make one item. Sure, the value of t changes for different types of item. Right. On the grid below, this is a weird question. On the grid below, draw the graph of n equals 60 over t for values of t from 1 to 4. Okay, so it wants me an accurate plot as opposed to a sketch. Right, well, I'm going to have to do a sketch, but I will label it to make it clear. So n equals 60 over t, and it wants me to do this for t. So n is 60 when t is 1. Excellent. So let's put these labels on. What's it labeled there? 1, 2, 3, 4. So we want to do 1. we want to know 2, we want to know 3, and we want to know 4. Right, and then this is n, this is t, so n is 60 for t equals 1. Then for 2, it's going to be 60 over 2, 30. So let's try and roughly do it to scale. It's going to be at 30. For n equals 3, 60 divided by 3 is 20. And then it's going to be divided by 4 is 15. 15. So if I were to sketch that, and obviously as t goes to 0, this goes to infinity. It's going to look something like this. I'm just going to go over those crosses to make sure Ben can read them. That one, that one. I should probably add these values in as well, shouldn't I? Okay, so this is n equals 60, this is n equals 30, this is n equals 20, and n equals 15. Okay, accurate enough. Right, good. Oh, there is a part B. Okay, so that's part A, my graph, and then for part B, what does it want me to do with this graph? Machine takes 3 minutes and 30 seconds to make a single item. So I've got to estimate this from the graph. Oh no, I didn't do an accurate graph and it wants me to estimate. All right, well, this is just not even remotely accurate. But I can probably estimate it from the numbers. So I want to divide by, I want to do n is going to be equal to 60 divided by 3.5, which is 7 over 2. So I can put a 7 over 2 on the bottom. So that's 120 over 7. What's 120 over 7? Oh, it's very close to 10 would give me 70, plus another 49 is 17. So I think 17. So n is approximately 17. And that's exactly what my graph says if I add this lovely 17 value to it. All right, I'm going with that. Okay, question 11. Ed and Faye are sharing some money. Lucky Ed and Faye. Right, question 11. So they're sharing £330 in the ratio 7 to 4. So we need to know 11ths of it. So nice, 1/11 equals £30. So therefore 7/11ths is going to be £210 and the remainder will be £120. Who gets the most? So I think Ed has the most money. I think, if I've possibly misunderstood the question, but I'm going with Ed has the 210, and that means that Faye has 120, and then Ed gives Faye some, so they have the same. So they need to end up with 165, because that would be half of the total. So therefore, Faye needs £45. So I think if we did 45 like that, then Faye now has 165, which is half of 330, and Ed is going to minus 45 from there. Will give me 165. Perfect. So same. Smile. So the answer equals £45. Excellent. Very generous of Ed to give Faye £45. All right, sequences, question 12. This should be fun, he says, not knowing what's in store. The next term of a sequence is made by adding the previous two terms. Which of the sequences follows this rule? Okay, so -9 plus 2 gives you -7. -7 plus 2 gives you -5. -7 minus 5 gives you -12. So the first one. So the answer is -9, 2, -7, -5, -12. And let's just check the others fail. -3 plus 5 would not be -2. That one fails. 0 minus 3 would be -3, but then do them again would give you -6. -1 minus another one gives you -2. Minus another one gives you -3, but then -3 minus another 2 would not give you 1. All right, yeah, first one. Good, first one I checked. Okay, question 13. The triangular cross-section of a prism is an isosceles right-angled triangle. Great. The volume is this. Use approximations to estimate the value of x. Oh, I don't know if I know the volume of a prism. All right, figure this out. Okay, so the volume of a prism is going to be the cross-sectional area, so the area of the triangle, multiplied by the height. So let's figure out the area of the triangle, right? So area of the triangle. Okay, and what do we know about the triangle? It's half the base times the height. It's got a right angle triangle, so the area is a half. The base is x, so it's half x squared. Okay, so it's half x squared multiplied by 8.14 has to give me the volume. So therefore I can say 102 centimeters cubed. The total volume must therefore be the area of the triangle times the height, which is 8.14. Right, so that's going to mean, if I tidy this all up, 102 has to equal 4.07x squared. Not really sure how I meant to estimate this, but let's try it. So I want to do x squared is therefore 102 divided by 4.07, which means x is equal to the square root of that number. So I think the idea is if I did 100 divided by 4, I get 25, and then x will be 5. So I'm guessing that's my approximation. So if I say, therefore, x is approximately the square root of 100 over 4, then that's the square root of 25. So that tells me that x is approximately 5 centimeters. Woo! All right, I'm happy with that. Question 14. These are going down like Skittles. This is great. I love this. Question 14. Here is a quadrilateral. It's a weird shape. All right, and I'm told some values. Okay, I'm going to draw a diagram then. So let's draw this funky looking thing and then include these values that they are giving me. Right. Okay, A is going to be 90 degrees. Right. So let's put the right angle in. A to B are in the ratio 5 to 3. Whoa, okay, fine. Okay, so if A and B are in the ratio 5 to 3, this is B. So if A is 90 degrees, then what do I know? I need to know what B is. So we know that A, B are in this ratio 5 to 3, which means that's 30. 5 to 3, which means 90. So 5 to get to 90 is 18. So 3 times 18 is 54 degrees. So B, therefore, is 54 degrees. Okay, so B is 54 degrees. Does that work? Ratio 5 to 3, let's just double check. 5 times 18 is 90. 3 times 18 is 36. It's 54. Yes, right. So B is 54 degrees. X and Y are in this ratio 1 to 3. Show that B equals X. Okay. So X and Y. So this is X and this is Y. Okay. So it's a quadrilateral. So I know that the total angle has to be 360 degrees. I think that's a fact. Yeah, I'm going to stick with that. I think the total angle has to be 360. Right. So let's write that down. So I think the total needs to be, I'm pretty sure that's right. Oh, I haven't even thought about angles in years. Okay. I think the total angle has to be 360. And I know A and B. And X and Y are in this ratio of 1 to 3. So Y is clearly 3 times X. Okay, so Y equals 3X. So what that means is the two I figured out, A plus B, which is 144. Therefore, 144 plus X plus Y has to equal 360. But that means 144 plus 4X equals 360, which is going to mean that 4X has to be 360 minus 144 is going to be 216. So therefore X should be 54 degrees. and B equals 54 degrees. So X equals B. Exclamation marks. All right, assuming, I'm pretty sure a quadrilateral is based on a quadrilateral needing to have a total angle of 360. I think I've got that one. All right, well, we're going on to the next question regardless. Okay, question, what are we on? 15. Here is some information about the test marks of 120. I love how they put in these like teacher-based marking questions. Here is some information about the test marks of 120 students. Right, complete the cumulative frequency table. Okay, I can do this. So you just add them up. So question 15A. So let's write this. So we've got mark, and then we're going to write it as cumulative frequency, and draw a little table. Right, so when m is less than or equal to 10, then we want 20 up to 50. Okay, less than or equal to 20, less than or equal to 30, less than or equal to 40, less than or equal to 50. Right, and then let's add in those columns. So if I just add them up, so we've already got that that's 20 plus 28 gives me 48, plus 40 gives me 88, plus another 20 is 108, and then plus 12 gives me 120, as it has to be because there's a total of 120 students. Good, so I think that's okay. Oh, I've got to draw another graph. Of course I've got to draw another graph without having the axes on my tablet. Right, draw a cumulative frequency graph. So, I'm going to attempt to draw this as accurately as I possibly can. Sorry, Ben, you'll have to just take my word for this. Mark up to 50. Okay, so we're going to have 0. Let's then go 10. That's about right. 20, 30, 40, and 50. And then that's going to be the cumulative frequency. Cumulative frequency down the y-axis. All right then, so what are we saying then? And this is mark M. Right, so at 10, we know that it's 20, and the total is 120. So let's add in some scale. So if that's 120, that's going to be 60. That's going to be 30, which means that's 10, 20, and you have to add all of these, aren't I? 40, 50. This is where I need that little SpongeBob thing that pops up and says, a little while later. All right, 70, 80, 90, 100, 110. Okay, just about read that. Right, so m less than or equal to 10 has a value of 20. So at 10, the value is 20. Put a little cross, let's do a cross, put a little cross there. At 20, the value is 48, so that's up near 50. At 30, it's 88, so that's up near 90, saying that's about there, he says. 40, 108, oh, these are tricky numbers, it's like up here. And then 50, we're at 120, so that's about here. So I'm guessing I meant to draw this in. All right, I'm going to go with it. So if I try and draw the graph, it's going to look something kind of coming up. And then it's going to flatten out at the top. All right, and then let's just go over those x's so that Ben can see them. Right, that's the best graph I can give you. Sorry, Ben. Okay, hopefully... Oh, no, there's more. I thought we were done with that one. Okay, students who scored 15 marks or fewer take another test. User will have to estimate how many students. Of course I'm estimating from a sketch not drawn accurately. I need square paper. All right, let's try and do this. So who scored 50 marks or fewer, take another test. So let's find the midpoint of this. We're going to go up, and then we're going to go across. And this is going to be terribly, terribly inaccurate. Now let's just look at those numbers. So we're going from 20 to 48. So it's going to be somewhere between the two. It's kind of increasing steepest at this section. Not quite yet steepest. It's steeper on the next section. It's going to be somewhere around 40. I think it's somewhere around 40. if I'm going to have a complete guess. It's definitely more than half is the point, because it's steeper, because we've gone from 20 in that first section to 28 in that second. So the gradient's like increased. I'm going to say approximately 40 students need to do another test. Sad face, because that's quite a lot of students. Bless. All right, thankfully we're now done with question 15. Did not enjoy that one. Right, 16, simplify. Oh, this looks fun. Love some algebra. 4x minus 8x squared divided by 12x minus 6. Okay, so factorize out. The top we've got, I can take out a 4x, and then I'm left with a 1 minus, that's going to be 2x. And then on the bottom, I can't take out a 4x, whoops. Well, I've committed to this, so I can take out there what can I take out? A 6. So if I take out a 6, then I've got 2x minus 1. Ah, it worked. We're good. Because now I can say I've got cancel those as long as I have the minus on the bottom. So minus 4x over 6. All right, minus 4x over 6. Yes, I'm going with that. Right, Toby is forming and solving equations. Good on you, Toby. The product of, oh, okay, to think about this. The product of half a number, let's write this down. The product of half of a number and 3 more than a number is the same as the square of the number. Toby uses y, I was going to use x. Damn you, Toby. Toby uses y to represent the number. Okay, so the product of half of a number, so y over 2 is half the number, and 3 more than the number multiplies it. So that gives me the product of half of y and 3 more, is the same as the square. So that's equals y squared. Fab. All right, I'm going with that. That's an equation Toby could form. Toby forms another equation. Of course he does. So that's part A, and now he's obviously using x, which says x is 9 over 8x. Okay, x equals 9 divided by 8x. Right, what are we doing, Toby? He wants to work out the values of x. Here is his working. Oh, got to find an error. Literally marking again. They love this. Examiners are clearly teachers. And they clearly don't like marking and want to make the students experience marking. He wants to work out the values of x. Here is his working. Okay, so x equals 9 over 8x. So if I multiply both sides, how would I solve this? I'm going to solve it and then compare mine with Toby's. So what I would do is multiply up and say 8x squared is equal to 9. I'd then say x squared equals 9 over 8. And then I'd say x is plus or minus 3 divided by the square root of 8, which is 2 root 2. That's what I would say. Ah, so he's not done that. So he said 8x squared equals 9. And then what he's done, so Toby has square rooted the 9 and the x squared, but not the 8. Sorry, Toby. His error there was he said 8x squared is 9, and then he square rooted to get plus or minus 3, but the left-hand side needs to be root 8 times x. Okay, good. Number 18. Here is an identity. Right, well, let's write that down. Question 18. Here's an identity. X squared minus y squared. Ah, good old difference of 2 squares. I love difference of 2 squares. Really helpful. Remember that. X plus y times x minus y. Use the identity to work out the value of this. Alrighty, so what we're going to say here is let x equal 193. Y is going to be 7. Therefore, I can say 193 squared minus 7 squared equals 193 plus 7 multiplied by 193 minus 7. So that's equal to 200 times, as the first bracket, 193 minus 7 is going to be 186. Yep, and it wants the answer, so you've got to do that. Fine. Oh, so 200 times 186, so let's double it and then add 2 zeros. So 186 times 2 would be 200, would be 360. 372, he says, with no conviction. Yes, that's right, 372, and then add 2 zeros. So 37,200 is the answer, I hope. Oh, and now factorising. Right, so that was A. Okay. And then B, we want to factorise 100a squared. Okay. 100a squared minus 81b squared. Nice. Difference of two squares again, because this is just 10a all squared minus 9b all squared. So I'm guessing we can now use the result from above now, because x is going to be 10a and y will be 9b from what we had above. So I know this is equal to 10a plus 9b multiplied by 10a minus 9b. And I think that's it. 10a plus 9b multiplied by 10a minus 9b. Yeah, all right, cool, going with that. Question 19. Circle the fraction that is equivalent to 0.1 forever. Hooray! Classic. Right, so 0.111111 is going to be 1/9. I know that, but I'm guessing they want some working. Maybe they do, maybe they don't. It's equal to 1/9, and I could show that by saying let x equal 0.111 forever. Then you can say 10x, therefore, is 1.11111 forever. So 9x is equal to 1 minus the other is equal to 1. So x equals 1/9. Smiley face, because that's what I thought it was. Awesome. Right. Number 20. I'm hoping we're near the end. How many questions can they have? A, B, and C are points on a circle. And CD is it's a diagram. A diagram they're going to have to draw less accurately than what they have. Though I like that all of their diagrams say not drawn accurately. Such a get out. Right, let's draw the circle and let's add in these things. So we've got A going out there. This one then comes down and is tangent at C. That one goes across to B. And then we're going up to A. Right, wicked. And then we've also got this diagonal. Okay, cool. So this is C. This one up here is going to be D. This one is A. And down here we've got B. And let's just draw big dots so I can make my diagram look more accurate and look like they all actually crossed. Especially this one. Right. Okay. Assume the triangle ABC is isosceles. That's nice of them to tell me. And AC equals BC. So that one equals that one. And that's isosceles. Okay, so ABC equals isosceles. So that means this angle, let's call it X, is the same as this angle. Also X, and then we know this angle is 180 minus X. Cool. I do know that the angles in a triangle for certain are 180. Still less convinced about the quadrilateral one. I'm pretty sure it's 360 though. Prove that AB is parallel to DC. And we also, nice, CD is a tangent, so we know that that angle, we know the angle to the center is therefore 90 degrees, but that doesn't necessarily say anything else. Ooh, this is tricky. This one's actually tricky. All right, so we want to show that AB is parallel to DC. So that means showing the angles are the same, right? And I know that one is X. And that's X, and that's 180 minus X. Now, what do I and don't I know? The tangent thing's got to be key. They wouldn't tell me that CD was a tangent unless it was important. So, what do I know about circles and tangents? So I'm pretty sure I want to say, there's something in my head saying that if you have a circle and a tangent to the circle, so it just touches it, I'm pretty sure that that forms a right angle with the centre of the circle. But we don't seem to have any centres on our diagram. Okay, so what else can we figure out then? There's got to be something about that tangent. Oh, there's got to be something about that tangent. Rack your brains, Tom. It's been too long since I've done circles and angles. So CD is a tangent. It's a tangent, so it's touching the edge of the circle. Okay, and then it's going across to B, and that's isosceles. And I know that AC and BC are the same. Right. But I don't know anything else about these angles. Okay. Don't know anything else about those angles. No. I'm going to have to call it. I don't know. I don't know my circle theorems. Sorry, everybody. Ben, I'm so sorry. I don't think I know my circle theorems. I think that they should be parallel, right? The diagram makes them look parallel. I'm convinced that they are parallel, but as I don't think I can argue it. So I'm out. All right, we're going to have to move on. That's 4 marks as well. Ouch. All right. Fingers crossed. The rest of it's all right. All right, let's do part B. Oh, we're changing it. So it's, in fact, triangle ABC is now going to be equilateral. Right, so don't like this question. So now they're all the same. So let's do them all in orange. 2, 3, 1, 2, 3. They're all the same. That's x, x. So this one will also be x. So I know if it's equilateral, the angles are 60 degrees. Right, so I now know that x is 60 degrees. And this is for part B in orange. Okay, tick the 2 boxes for the statements that must be correct. AB is parallel to DC. Do I know that? I feel like that should still be true. There's nothing stopping that from being true because it's still, if it's equilateral, it's still isosceles, and it was true for isosceles. So yes, so AB parallel to DC. Yep, that's correct. And AC bisects angle BCD. Maybe. AC bisects angle BAD. BAD. If it's equilateral, would it bisect the tangent angle, or would it bisect the one in the top corner? Given that these are parallel, so if these 2 lines, I've drawn a terrible diagram. If these 2 lines are now parallel, then I want to say it's going to bisect which one? Oh, I'm guessing at this point. I'm really bad at angles. I want to say AC will bisect. It's more likely, surely, to be which one? It would help if I had an accurate diagram. If I was actually, let's look at their diagram. So if I was trying to draw this, which one would be correct if it was equilateral? BAD. Right, I'm going with BAD. It's a bit of a guess. As we've seen, I can't do circle theorems. I think AC bisects angle bisects BAD. Right, I think they're the 2 correct ones. Really don't like that question. Let's very swiftly and very happily move on to question 21. Oh, awesome. This is going to make me feel better. Solve some simultaneous equations. Right, here we go. So 2x plus 3y equals 5p. And we're told that y equals 2x plus p. So I can rearrange that to say minus 2x plus y equals p. So if I add those 2 equations together, that tells me that 4y equals 6p. So y is equal to 3 over 2 times p. And therefore we can say 3 over 2p equals 2x plus p. minus p from both sides says that p over 2 equals 2x. So x is therefore p over 4. Right, and let's just check that makes sense in the other one. So 2x would be p over 2, plus 3y would be 9p over 2, 12p over 2. Ooh, let's just check that. 2x would be half of p. 3 lots of it would be 4.5. So when you add 4.5 p's to half p, you get 5p. Perfect, so that's correct. So y is 3 over 2p, x p over 4. And it was so much better for 4 marks than that silly circle. I'm not happy about that. Put it out of your mind, Tom. All right, move on. Good exam technique. We move on, we ignore it, we forget about it. 22. Right, ABC and AC. Oh, it's another triangle question. ABC and ACD are triangles, and K is a constant. Show the vector CD is 6a plus 4.5b. Right, so in that case, I'm going to draw this diagram. So what have we got? We've got B going to A with some vector. We've got some other vector going over here. We've got this one, and then we've got something coming down. Right, so we're saying that that is K times the vector A. Fine, this is C. This is going to be 3 lots of B. Sure, this one is 6A plus 7.5B. Going out to the point D, and that's going in from A to D. So if I want to go from, let's do it in a different color. If I want to go from C to D, so it's asked me for, I've got to travel minus equals minus 3b, and then plus A to D. Okay, so then plus 6a plus 7.5b. So putting that all together, that's going to be 6a plus 4.5b, which was the answer. Hooray! Okay, good. BCD is a straight line. Okay, good. Work out the value of K. Sure. So BCD is a straight line. That means it has to have the same direction. Okay. So therefore, can I work out BC? So let's work out BC. So B to C is equal to KA. So I go from B to A and then go from A to C. So that's going to be positive plus 3B. Right, so B to C is that. And that needs to have the same direction as CD. So it needs to be in the same ratio of the amounts of A and B. So therefore, so what I can write this, we need same ratio of amounts of A and B. So therefore, we can say, what have we got? A is, what ratio are they in? So 4.5b. So A is 4/3 of B. So therefore K equals 4. Because then multiply 4 by 1.5 and you get your 6A. Multiply 3 by 1.5 and you get 4.5b. So K equals 4. Woo! Okay, I'm not sure you're working. Yes, just did. Right, question 23. Simplify 8 to the 4th divided by 32 to the 2/5. Sure thing. So, and he wants this in powers of 2. I was going to do that anyway. So that's 2 cubed to the power 4 divided by 32 is 2 to the 5. I think 2 cubed is 8. Yes, 2 to the 5 for 32 to the power of 2/5. So this whole thing is therefore 2 to the 12 because you multiply the powers in the bracket over 2 squared. So that equals 2 to the 10. All right, 2 to the 10. Good. Question 24. We're told that f of x equals sine of x minus 90 degrees. Ugh, degrees, prefer radians. Circle the value of f of 0. Right. Okay, so f of 0 degrees, so we want when x minus 90 degrees equals 0, so x equals 90 degrees. Okay. No, my bad, that's completely wrong. Don't do that, Thomas. Let's go back and let's actually answer the question. So if f of x is that, and I want to know f of 0, yes, so therefore if that's f of x, f of 0 is sine of minus 90. Okay, so sine of 90 is plus 1, so that's minus 1. All right, answer is minus 1. Got to be getting there. Question 25. I really should have looked how many questions there were. All right, more diagrams. Okay, P48 is a point on a circle centre O. The tangent at P intersects at these positions. Sure. So the gradient of the tangent is minus a half. Right. How would I do this? So what have I got? I've got a circle. We've got an x-axis and a y-axis. We've got a tangent coming in like so. And I know that this line is passing through the point 48. Great, so therefore the gradient of the line, the gradient is simply the change in y over the change in x. Do I know that yet? Maybe I don't know that yet. Oh, okay. Think about this. So what have I got to show? So the gradient of the tangent is minus a half. Right. Right, what do I know? I know the circle. Let's do the circle equation, I think. I assume this is GCSE. That's how I'm going to do it. So the circle, therefore, has equation. Right, so I know that 48 lies on the circle. And that equation is x squared plus y squared equals, let's call it capital R, the radius squared. I'm hoping this will help, it might not. So what do we know? We know that x is equal to 4, so we know that 16 plus 64 equals r squared. So we know that the radius is therefore the square root of 80. Don't know if that helps. Okay. What else can I say? So if I know a point that a line passes through, it's got a negative slope based on the picture. Wait, can we not say negative slope from picture? And then just say because of the value it passes. I'm pretty sure we can just do this. So because it passes through the point 48, therefore the change, so therefore the gradient is just equal to the change in y over the change in x. So if I were to kind of draw something down like so, so then I know, what do I know? Okay, so let's pretend it was the positive one, and then I know that it's minus the inverse of the positive one. Right, so I can say, okay, so I'm going to say, this is so not the way to do this question. I'm going to say that the perpendicular gradient, we know that. Right, so if I know the perpendicular gradient, I'm going to say that's the change in y, which here is clearly 8. Perpendicular gradient is 2, 8 over 4, which equals 2. And then you say the product of gradients is minus 1. Therefore, the gradient we want equals minus a half. Absolutely not how you do that question, but I stand by it. Okay, 25b. Work out the length AB. Right. And I worked out the radius. Now it's helpful to know the radius, okay? So let's try and add this to the diagram. So I know these points A and B, so what do we know? A is at the bottom and B is at the top. I know that the radius of the circle, okay. So I know the radius of the circle is the square root of 80, sure. And what am I trying to get here? I'm trying to find the length A to B. More geometry questions. I'm so bad at geometry questions, apparently. Okay, what do I know? I want the length AB. I know it has a gradient, and I know the point it goes through. Right, I can work out its equation. Let's do that. Okay, we're going to get there, and then it's a triangle problem. Whew, I thought I wasn't going to be able to do that one as well. Okay, so what we know then is, and this is going to be part B, so 25B, we know that M, the gradient of our line, is minus a half. So if I try and do y equals mx plus c approach, I know I'm going through the point P, which is given by 4, 8. So I sub them in, I find c. So therefore, y, which is 8, equals minus a half times 4 plus c. This will give me c, so 8 equals minus that, so minus 2 plus c, so c is 10. Right, so the line I've got, therefore line equation is equal to y equals minus half x plus 10. So if I draw that, I don't need anything to do with the circle for this. If I draw that, I know it's going through these 2 points. And I know that when x is 0, y is 10. So I know that length is 10. At y equals 0, I can say that half x is 10, so I know that x equals 20. That seems big, but sure. So this one is 20, and I know that's a right angle. So that's 20, that's 10. So Pythagoras, don't think so you might do it again, but I'm going for it. So Pythagoras tells me that 20 squared, 400, plus 100 equals, let's call it c squared. No, let's call it d squared because I've already used c. So d is the square root of 500. And the square root of 500 is, it wants me to factor that out, so d is equal to 10 root 5. All right, so therefore AB equals 10 root 5. We hope. All right, question 26. The turning point of a graph has this x coordinate, right? So x is going to be x plus a squared plus b. And I'm told that the x, the x coordinate is minus 2 when it turns. Okay. I kind of want to differentiate. I think I'm supposed to differentiate, but I'm going to totally differentiate. Okay, so if this is my graph, I therefore, totally cheating here, but I'm doing it. It's allowed, I know this. dy by dx is therefore going to be 2x plus a. Right, and then I can say from that, therefore, turning point occurs at when 2 times x plus a is equal to 0, so when x equals minus a. Okay, so x equals minus a, and I'm told that it has x coordinate minus 2, so therefore a is equal to 2. Right, excellent. So if a is 2, so I can now say y equals x plus 2 squared plus b, and this has to pass through the point 3,1, pass through this point at 3,1. So we're going to plug those in. So 1 equals 25, 3 plus 2 is 5 squared, 25 plus b, so b equals 24. Okay, and then we want to know the y coordinate of the turning point. So the equation is y equals x plus 2 squared plus 24. And the turning point therefore occurs, so, and then you say turning point at x equals minus 2, which means in the equation y is equal to b, which is 24. So the answer is 24. Question 27. I hope this isn't never ending and it's just like some kind of sick joke. The questions never end. Okay, angle x is acute, so that means it's less than 90. I had to remember that. Okay, so x is less than 90, so let's note that one down before I forget. So x is less than or equal to 90 degrees. Okay, and then we're told that cos of x is going to equal sine of 60 degrees times tan of 30 degrees. Nice, okay. And I need to know x. All right, I can work this out. So graphs, sine of 60. So let's draw the sine graph. So the sine graph goes up and looks like this. So 60, it's increasing. So it's quite near the top, but not quite at 1 yet. So I want to say it is sine of 60 degrees. What's that equal to? It's not quite 1, but it's bigger than the 30 degree one. I think it's root 3 over 2. I'm going to say it's root 3 over 2. Okay. Yeah, he says. Yeah, root 3 over 2. I'm going to say sine 60 is root 3 over 2. Tan of 30. Okay, so to figure out tan of 30, I need to know tan of 30 degrees is going to be sine of 30 over cos of 30. So that's sine of 30, again, based on my graph, is going to be, sine of 30. Is that one not 1 over root 2? Is that 1 over root 2? Is that root 2 over 2? Ooh, I can't remember. Sine of 30, I think, is that root 2? No, it's not, is it? It's a half. That's a half. Sine of 30, I think, is a half, he says with no conviction. Okay, I think it's a half over cos of 30. So let's draw the graph of cos. So that one comes down and then obviously does whatever. So it starts at 1, and when you're at 30 degrees, you're going to be like here. So that's the big one. So that's root 3 over 2. So they cancel, so it's 1 over root 3. Does that sound right? Tan of 30, 1 over root 3. I buy that. I think that's right. So that's 1 over root 3. So therefore, cos of x is equal to sine of 60 root 3 over 2 times 1 over root 3. This looks promising. So that's going to equal a half. So what value of x makes cos a half? I think it's 60 degrees. All right. Yeah, because that's the lowest. Yes. Has to be, he says. I'm going with it. 60 degrees. Okay, next question. Ah, yes! End of questions. Absolute sight for sore eyes right there. 27, what an odd number of questions to end on. 27 questions down. I have finally finished my GCSE maths exam. Well, I didn't answer, I think it was at question 20, the one with the, I can't believe I forgot my circle theorems. Ben, I'm so sorry. I don't know, maybe Ben forgot his circle theorems. I have no idea. We'll find out when we mark each other's scripts. So we're going to record all of the marking process, and then in a follow-up video, we're going to have a discussion about how we both did, presenting each other with our final marks. So that should be fun. And also talking through maybe some of the different approaches that we used when trying to get our solutions. So do keep your eyes peeled for the marking video. As for this one, thank you as always for watching. Please do subscribe if you've enjoyed the video, and I'll see you all soon. Take care.